sunshine. I realize I am in sunshine. The skies are turning blue. Would you like to?
I want to come back to climate change just for a little bit. I've done a lot of evolution on this channel, but haven't really touched climate change yet.
Yeah.
And so one of the reasons I really want to talk to you is because I consider you kind of one of the key voices in climate change. There's a few other people I think probably here at BYU and around the nation that are Mormons, but that are, do research in climate change and understand the topic and could be a good voice. So could you just kind of lay out, what do we confidently accept in climate change? These a lot of times people are always like, so what do we know? What do we know? Could you just kind of lay out quickly, what do we confidently accept as true? What should we accept with joy as this channel?
Yeah, so here's what you should accept with joy. First of all, humans have had an impact in our climate, right? So you'll hear people say, well, the climate's always been changing. We can look out. We can see there used to be glaciers here, and they're not now. And Lake Bonneville used to be this full. And, climate naturally changes. This is just natural. And we can, and the response to that, my first response often is like, well, how do we know it's like that? And they'll say, well, the scientists tell us. And they're like, well, what are the scientists telling you now? Why would you believe that, but not believe what we're telling you now? But in general, this is what we know, right? Humans have burned a ton of fossil fuel. We've done a ton of, right? We've cranked gigatons of carbon dioxide into the atmosphere, mostly by burning fossil fuels. There are other greenhouse gases and stuff like that are important. But human activities are responsible for the climate-driven changes that we see in the last 150 years, like dramatic, right? And the Earth does change naturally over time, but it takes thousands to tens of thousands of years for those changes to be felt. And we're doing in decades, we're having an effect that historically has taken thousands and thousands of years, even to get to this point. And anyway, I don't want to get too nerdy with the data.
So rate, I always say this to my student, rate is an important concept that we have to say. The speed at which it's happening is unheard of.
Absolutely, that's incredibly unheard of. Yeah, it's we don't see anything like this in any of our records of Earth's temperature, whether those be sediments or ice cores or tree rings or you name it. There is no precedent for the rate of change that we're seeing right now. So that's the first thing. Change is real. And the second one is that humans are driving that. And people sometimes ask me, well, how do you know what humans do? And it's pretty much like simple math, actually. You do it on the back of a napkin, right? You can measure all the drivers. You can say, these are all the factors that are associated in elevating Earth's temperature, right? And then you just measure the contributions of each of those to the difference that we see in temperature. And then you just pull each one of them out, one at a time. Right? You can say, well, there's volcanoes, or there's water vapor, or there's contrails from airplanes, or all kinds of stuff, right? All of the different explanations that you may have heard for climate change. And then you can just look to see what's left and how well that fits the line, how well that fits the curve, right? And so we have really good idea, not only that we're responsible for it, but what each individual driver contributes to the overall difference that we see in temperature. In the last 150 years, mostly. Yeah, so it's fairly simple math. It's not complicated to figure out what's causing climate change and who's responsible for it, right? And what magnitude each of those drivers contribute to climate change. It's pretty straightforward.
Okay. Sometimes I hear, well, but this Earth, we're in charge of it, right? We're the stewards. And I think there's good arguments to say, yeah, we better take care of it then, right? But sometimes I'll hear, well, yeah, but there's plenty to go around. There's even scriptures that talk about how the Lord has prepared this earth for everything. There's plenty to go around, and plus the millennium's coming here pretty soon anyway. So why are we trying to prepare for thousands and thousands of years of living on this planet? What would be your response to kind of those pushbacks that you sometimes get?
I identify with those. I was an undergraduate student here at BYU when Secretary of State James Watt, or Secretary of the Interior James Watt, actually said that we shouldn't be worried about environmental issues because Jesus is coming back soon and he'll take care of it, right? But that kind of contradicts, other... I'm not going to go deep into this. There are a lot of people who are here at BYU who like that's what they do. They talk about, you know, this idea of stewardship, right? And that really contradicts the notion of stewardship that's in our sacred text. Like as a member of the Church of Jesus Christ of Latter-day Saints, like our sacred texts are very clear about what stewardship is and what our obligations are. And so it is important for us to be stewards, but the question comes down to like, well, is there really enough for everybody, right? The earth is abundant, there's enough for everyone. And the answer to that question is, like, even right now, if you do the math, the answer is yeah, it is abundant. But it's not equally distributed very well, right? You know, like those of us in North America, like, are consuming like tremendous amounts relative to, you know, somebody in Bhopal, India, right? Like not just in fossil fuels, but in water and all of the energy sources, right? And so, like, yeah, if we could level that playing field out a little bit, you know, like, yeah, there is enough for everybody. But the earth is not a finite, it is a finite resource, right? You know, there's a finite amount of energy that's hitting this earth that runs the machine and makes it all work. And there's a finite amount of topsoil, right? There's a finite amount of fresh water, you know, and so, yeah, the earth has what's like your listeners who are like elk hunters or deer hunters or duck hunters or fishermen, right? There is a carrying capacity, right?
Yeah.
For those populations, and it's no different for humans, right? So at some point you can reach the point at which, you know, earth reaches carrying capacity, right? There is a maximal amount where that's all that the earth can sustain. And that shifts, right, depending on where our priorities are. You know, like how rich do I have to be? How big of a car do I have to have? How much food do I need to eat? Or like how high on the food chain do I need to eat? If I drop it down, then somebody else can, you know, elevate their like a standard of living, that sort of thing.
Okay, so in summary, climate change happens. Humans have something to do with it. We should be better stewards of the planet.
We should be better stewards of the planet. Now, but that's a hard thing, right? Because we can say, well, is climate change good or bad? You know, because like I'll have somebody say, well, it's like 115 in Arizona today, and you're telling me that the Earth's average temperature is going to go up to 1 degree. Okay, so it's going to be 116. Like, whoa, you know, like big deal. And so you sort of have to turn that back around. You know, I was in Antarctica once when what's his name? The presidential candidate from Arizona, John McCain came to visit, right? And he was like, you know, they were showing him like the water treatment plant, you know, and the recycling center. He's like, I don't want to see that. I want to talk to scientists and learn about climate change. I want the straight dope on climate change. So he got us all in this room, you know, all together, and all of the scientists that were on the station at the time, we just went up to the whiteboard, you know, and slides, and we just given him the data, right? And then afterwards, he's like, yeah, okay, like he was totally on board. And he's like, but how do I explain this to my constituents back home, you know, who are like, so the earth gets 1 degree warmer, whoop-de-doo. And a colleague at USC who's like, well, you know what it's like in the summertime in Washington, D.C., right? And you know what it's like in Boston, like big difference. It's like that difference is 1 degree mean annual temperature between Boston and Washington, D.C. So take that back to your constituents, right? Like that 1 degree makes a big difference in what lives where, like what the climate's like what you can grow, like air, that matters to everything, right? And I remember hearing that response thing, yeah, that's a good way to demonstrate to somebody that they should care about it. But in general, like, you know, is it good or is it bad? You know, we ask these questions because like science can't tell you if it's good or bad. Right?
Right, that's not the point.
Right? All we can say is, well, you know, this is what's going to happen to your water resources. Wow, this is what's going to happen to forest fires. This is what's going to happen to our growing seasons. This is what's going to happen to plant pathogens, right? We can tell you that, and then you decide if that's, you know, a good or bad thing. And so, like, that's another thing that I struggle with when people are like, well, so what? Like, I don't care if it goes up a degree or two. You know, like science are always telling us this is bad. Like, no, we're not telling you it's bad. We're telling you that you know you're going to have more frequent fires. Okay, that's reality. You tell me if you think that's bad or not, right? Yeah. Or we're going to have more problems with pests, or we're going to have more problems with drought. You tell me if that's a bad thing. and if we should mitigate it. And right, like, you tell me if you want to leave that for your grandkids, right, or your great grandchildren, or like, how far into the future does your vision go? Does your vision carry? Right. So anyway, that's where I have to leave those discussions.
So I think where I wanted to ask you about your own research, like. Mm-hmm. What of your own research has maybe solidified some of these principles, whether it's about climate change or evolution? I mean, have you seen, like, because you learned all of this from the books and you learned all of this by reading, but what of your own research? Has there been anything in your own research that was just like, wow, that like really demonstrated to me this principle or this principle?
Yeah, we had a paper that came out a couple of years ago where, I'm part of a long-term ecological research project where we go back to the same places year after year after year, and we measure a lot of the properties of the ecosystems, everything from like temperature to the soil moisture to soil salinity, soil chemistry, and then all the organisms that live there. And so we look at the climate drivers, like what's going on with the climate. Is the climate changing there? And we notice, yeah, it's changing a little bit, but it's kind of weird. You got a lot of interannual variability. It's hard to tell the difference between just like a wet year and a dry year versus climate, right? But our records go back 30 years, right? So we, with that long-term kind of data, you can tell the difference between climate and interannual variability. And we have a postdoc that, when I looked at the data, I was like, I'm not sure there's anything emerging from this, and a postdoc's like, well, let's throw some statistics at it. Let's do some analysis of these data. And the analyses of the data just came back like clear as day that, that of course the climate had been changing, and that had affected things like soil moisture and soil chemistry and soil productivity. And then that had affected things like the organisms, the abundance and the diversity of the organisms that were in these soil ecosystems. And I was like, wow, like astonished to see how clear those changes were, how directional they were. And then the implications that have for ecosystems, soil ecosystems, like all over, like our agricultural ecosystems, our managed ecosystems, like forest ecosystems and things like that. I was like, if these types of changes that we're measuring here, like in that particular ecosystem, is not at the same magnitude that you would have in the Arctic, for example, or even in some of the northern temperate hemisphere forests and agricultural areas. And so I was just like, dang, like this is full on legit, and it has full on legitimate impacts. Like the consequences of this could be really big. So like, awesome. Yeah, and I was surprised. I was like, I don't know, and then once we completed the analysis, I was like, dang.
Yeah, that's kind of a cool moment when your own research kind of, solidifies some of these ideas, right? That you always are like, yeah, this is what's happening. Then your research does that.
Sunshine with me. The doors are open, the skies are too. Sunshine is coming in for me and you. Sunshine.